In this video, we are going to be looking at the nature of quadratic roots, and this helps us to understand the behavior of the roots of a quadratic equation even before solving it. And yes, we can know details about the root of an equation even before solving it. We can know if we are going to have a complex root, if we can have a real root, the same roots for a particular quadratic equation, or if even we can also know if you factorize or not just by looking at the quadratic equation. So in this case here, we say that if ax squared plus bx plus c equal to 0, then this is the root of the equation. So this is the general form of the quadratic equation, and so that if the quadratic equation is of this form, then it can be solved using this. That's the almighty formula, and this x is the solution. Now we basically know that a quadratic equation has two roots. Those roots are what we denote as this. The first root x1 equal to minus b plus, here we have plus or minus, so the first root is this one, b squared minus 4ac over 2a. Then the second root is this, minus b minus square root of b squared minus 4ac over 2a. So these are the two roots of this quadratic equation. Now if you observe very well, the only difference between these two quadratic equations is this. But now there's something even much more interesting that gives us a lot of details. Now first thing you have to notice that when you have a number, square root of a negative number, from the number system we did, we saw that square root of a negative 1 is equal to I, right? That's the imaginary number. So now this square root now is now pointing us towards the direction that something very, very interesting could happen there if these factors here behave in some way. So these factors here, which is very, very essential in determining the solution, because if you look, this minus b here, this minus b here, so what determines majority of this solution is this factor inside here, and that's what we call the discriminant. That is b squared minus 4ac. So you see that if this b squared minus 4ac is negative, right, if we evaluate it, you know, these are coefficients of the quadratic equation. If we evaluate it and let's say eventually we get negative, we'll see that this particular part will be like an imaginary part, right, because of this root sign. And if we evaluate it and we'll get something that is greater than 0, we see that the square root will be a real number. So this factor here that determines the nature of that solution is what we call the discriminant. Now we're going to proceed further to see the interesting properties that came out of this discriminant. Now remember, these are the solutions of the quadratic equation, right? This is the first solution, this is the second solution. So let's see how these discriminants actually affect the solutions of the quadratic equation. So we say that if we have our quadratic equation like this, plus bx plus c equal to 0, if that is our quadratic equation, then this is the solution, minus 4ac over 2a. Now, like we have said before, this is called the discriminant, right? So if the discriminant now, b squared minus 4ac, is less than 0, right? If it's less than 0, we see that we are going to have an imaginary root here, right? Because it will be like, let's say we solve and get square root of negative 4. So we'll be having square root of negative 4 here, which is, say, square root of 4 times square root of minus 1. So we're having 2i plus or minus. So this thing now will affect the quadratic equation entirely. It's going to affect the solution. So that from here now we can basically tell that if the discriminant now is less than 0, we are going to have no real roots. See that the roots of that particular quadratic equation that such happens, is not a real number, right? If you plot it on the graph, it's not going to cause the x-axis at any point. So if this discriminant now is now greater than 0, we see that if this is greater than 0, we take the square root of a positive number, we are going to get a real number. So we say that this now will give us what? Real roots. Right, it's going to give us real roots. Now what if the discriminant now is now equal to 0? if the discriminant is equal to 0, you see that this particular part of the quadratic formula, that means this particular part of the solution will totally vanish, so that we'll just be left with what? Minus b over 2a. Plus or minus 0 will not have any effect, so that the x1, that means the first solution, and the second solution will not have any difference. That means they'll just be the same. So this one will give us what? Equal roots. Equal roots. Now, so one thing we need to note now that is very, very important. We know that this almighty formula can solve all the quadratic equations, right? But like we saw in the previous video, some quadratic equations cannot be factorized. So how does this discriminant help us to know the quadratic equation that can be factorized? Now, the quadratic equation that can be factorized is when the square root of the discriminant is a whole number. That means it can be factorized. Yes, when this discriminant, the square root of it is a whole number, then we say that it can be factorized. So basically, we can say that if the square root of the discriminant is a perfect square, or 1, or 0, or square root of 0 is 0, we can say that it can be factorized. So this particular one, obviously, it can be factorized when the discriminant is 0. Now, when the discriminant is greater than 0, but the square root is not known, we can't factorize it. We can't have integer factors of it. Exactly. So we proceed further to see example of where these things apply. That means I'll give a quadratic equation and we check the discriminants and we tell the nature of it, right, before we go into solving it, so that before you even start solving, you really have an idea of what the solution should look like. So let's proceed further to solving some quadratic equations using this. So if we have a quadratic equation like this, x squared plus 6x plus 9 equal to 0, right? Now, first of all, let's check the discriminant. The coefficient of a here is what? 1. A is equal to 1. Now, what we are doing here, we are comparing it to the general form, ax squared plus bx plus c equal to 0. This is the general form, right? So from here now, say that the coefficient of x squared, which is a, is 1. Then the coefficient of b, which is 6, b is equal to 6, is what? Okay, coefficient of b is 6. Then coefficient of x, which is b, is 6. Then the constant term is what? C, which is what? 9. So if we check the discriminant, b squared minus 4ac. Now let's see the discriminant. B squared is what? 6 squared minus 4 times 1 times what? 9. 6 squared is 36, right? Then this times this will give us what? Minus 36. So when we do this, we say that it is equal to 0. Now remember what the third case say. The discriminant now is what? Equal to 0, right? So if we solve this equation from what we just stated now, we should have the same roots, and since the square root of this is a whole number, we can be able to factorize this particular expression. So let's see whether these are our findings, whether they are correct or whether they are wrong. So first of all, we'll see if we can factorize this expression. Is there two numbers that we'll add and we'll get 6? Then when we multiply them, we are going to get 9. Yes, 3 plus 3 will give us 6, right? And 3 times 3 will give us what? 9. So we have gotten two factors. So we can factorize this then. So we have x squared plus 3x plus 3x plus 9 is equal to 0, right? So we can factor them like this. So we bring out x from here. We have x plus 3, right? From here now we see that the common value there was 3. We bring out 3, we have x plus 3. So it's already showing up. So we have here as x plus 3 and what? X plus 3 equal to 0. So this is a quadratic equation and we have to follow it as it should be. So from here now we have that this was x plus 3 equal to 0. Then we have here as x equal to minus 3. So here we have x plus 3 equal to 0. Then x equal to minus 3. So you see that what we had initially was correct, because the discriminant of this is equal to 0, and this, when it's equal to 0, the rule say we have what? The same root. So we have that x equal to minus 3 was twice. So this is for this particular one. So that x equals to minus 3 was twice. So this is the solution. X equals to 3, x equals to. Now if this is plotted in a graph, for example, if this is a graph, for example, this x we'll see that this minus, let's say this minus 1, okay, minus 1, minus 2, minus 3. Space is not challenge. Okay, if this is plugged in, you see that this function now is going to go like this. The graph will just touch this x and does this minus 3 points. Right? It's not going to cut at 2 points like this. No, it's going to touch it because the discriminant is 0. It has only one solution, what, twice. Remember, it must have two solutions, but that two solutions in this case are identical. Exactly. So let's see more problem and solve them and verify the other remaining ones. Let's look at this particular problem. X squared plus 2x plus 2 equal to 0. Right, so let's first of all check the discriminant of this particular quadratic equation. So the discriminant now, a is what? 1. A is equal to 1, b is equal to 2, c is equal to 2. So if we say b squared minus 4ac, what do we have? B squared is what? 2 squared minus 4 times 1 times 2. This will give us what? 4 minus 8, which is equal to what? Minus 4. The discriminant is what? Less than 0. Less than 0. And what the root tells us that is going to give us what? A non-real root. That means it's going to give us a complex number. So if you look at this thing now, is it possible to factorize this stuff? No, it's not possible because there are no two numbers you multiply to get, you add to get 2. When you multiply them, you still get 2. They are no number, it does not exist. So this expression cannot be factorized. You can only solve it by completing the square and using the almighty formula. So let's solve it using the almighty formula. We'll see that the root is going to give us a complex number. Okay, so we have the almighty formula as s equal to minus b plus or minus square root of b squared minus 4ac over 2a. We have that a is equal to 1, b is equal to 2, c is equal to what? 2. So we can just go into substitute. So we have x equal to minus b is 2 plus or minus square root of, okay, we can still solve this because we have already solved this in discriminant, but let's just solve this for clarity. B squared is what? 2 squared minus 4 times 1 times 2 over 2 times 1. So this will give us, this one is, so we say that s equal to minus 2 plus or minus square root of 4 minus 8 over 2. So this means minus 2 plus or minus square root of minus 4 over 2. Now square root of minus 4 is same thing as say square root of 4 times square root of minus 1. Right? So square root of minus 1 is what? I. So from here we have that x is equal to minus 2 plus or minus 2i over 2. Right? So we now have the solution of this as this. But the first solution is 2x1 now is equal to minus 2 plus 2i. When you divide through by 2 over 2, which is what? Minus 1 plus I. The second one we have x2 is equal to minus 2 minus 2i. Because we have plus or minus here, this is for the plus and this now is for the minus over 2. So when we divide, we have that is equal to what? Minus 1 minus I. So these are the solutions. So that this is an imaginary number, this is a complex number made up of real parts, imaginary parts. This is also a complex number made up of real parts and imaginary parts. So you see that the discriminant tells us what? The absolute fact. So before solving any quadratic equation, you use the discriminant. You can even do it with your eye because you say b squared, just say 2 squared minus 4 times a is 1, so b squared 4 minus 8, just minus, oh, it's going to give you minus 4. So I won't waste time trying to look for a factor and say, this thing cannot factorize, it cannot factorize. No, you don't have to waste time. When you do the discriminant, you know exactly how the nature of the root would be and you proceed to tackle it straightforward. Exactly. So let's look into more example on this. We have x squared plus 7x minus 11 equal to 0. Right? We have this now as a quadratic equation. So let's look for the discriminant. The value of a here is what? A is equal to 1, b is equal to 7, c is equal to what? Minus 11. So say b square minus 4ac. So have b square is what? For 7 square, this is 7 square, which is 49, minus 4 times minus 11 is equal to what? 49 plus 44. 49 plus 44 is going to give us what? 93. Right? 93 is greater than 0. It's greater than 0. But it's not a perfect square. So see that this is going to give us two distinct roots, but we cannot factorize it. We cannot find two numbers that when we add them, it's going to give us 7. But when we multiply them, it will give us minus 11. There are no such numbers. So this particular expression cannot be factorized. You can only solve it using the almighty formula. So I want you to solve this problem now using the almighty formula and put the answer in the comment below. You see that you have two distinct roots that are real. That means there's no imaginary number. You are not going to encounter any complex number along the line. So please solve this question and put it in the comment below. I want to see your solution. So let's move further to verify more about this. Okay, so now let's look at this particular problem. X squared plus x minus 56 equal to 0. This is a quadratic equation, and from here we know that a is equal to what? 1, b is equal to what? 1, c is equal to minus 56. So you can check the discriminant of this, which you have as what? B square minus 4ac. So b square is 1 square minus 4 times a is what? 1, c is what? Minus 56. So this is going to give us 1 plus, now this plus 2 to 4, 56 times 4, 2 to 4. So this is what? 2 to 5. So you see that this 2 to 5 now is greater than 0. That means we are expecting to have 2 3 roots. Now, can we actually factorize this? Yes, we can factorize it because the square root of 2 to 5 is equal to what? 15. So the square root is, this number here is a perfect square. So we can actually factorize it. Are you seeing it now? We can factorize this thing. You can factorize this because we already saw from the discriminant that the square root of this is a whole number. So we don't need to go through the almighty formula because we can easily factorize it. So from here we are going to look for what two numbers can we multiply to give us this, so that when we add them we are going to get what? 1. You can use factor method. You can just, like, when you have solved it multiple times, you can easily tell it from your eyes. But let me use the division method and show you how to do it. So here you have what? 56, because when you do 1 times 56 you still have what? 56. So 56, 2 divided this, we are going to get what? 28. 2 divide 28, we are going to get 14. 2 divide 14, we are going to get what? 7. 2 cannot divide 7. So 7 divide 7, we are going to get what? 1. So these numbers now, 2 times 2 times 2 times 7. So we are going to look for how do I arrange these numbers. Now, if I know that when I multiplied all of them, it's going to give me 56. You now say, how do I arrange these numbers now, so that when I add them, it's going to give me this. So when you finish this method now, what you should be looking at is how the sum of the roots will be, or how the addition of the factors will be. So when you say 2, add it to this thing, it does not make sense. 4, there's no way you can add 4 and 14 or put negative sign whatever to give you 1. So you look for this one now, you see that this 8 and 7. So if you say 8 minus 7 now, 8 and minus 7, when you add them, you're going to get 1. So you know that this is the factor of this particular expression. I believe you understood this thing. Now you can pause this video and go backward a bit and understand this process, because this is actually what factorization helps you to do. Is that clear? So pause the video and step a bit backward and understand what we did to get these factors. So these are just how to get the factors. So from here we can see that the factors of this expression is x squared to have plus 8x minus 7x minus 56 equal to 0. So this now satisfies them. So we can write this now in bracket: x squared plus 8x plus minus 7x minus 56 equal to 0. So from here now we can quickly factor out some similar terms here. So when we factor out x, you'll have x into x plus 8. So from here we have factor out minus 7. We have what? x plus 8 equal to 0. So we can easily group them, x minus 7 and x plus 8 equal to 0. So when we equate both sides, we see that x minus 7 is equal to 0. That means x equal to what? 7. Here we have x plus 8 equal to 0. And when this one crosses, you see that x is equal to minus 8. So these are the solutions. So that we're having two distinct roots. Now, if you want to plot the graph of this function now, it's going to be something like this. So if here is minus 8, for example, here is minus 8 and here is 7, right? The graph is going to cut this minus 8 and 7. It's going to cut at two distinct, these 2 points now. These 2 points, you plot the graph now and you check these 2 points, they are minus 8 and 7. So this is the solution of this particular quadratic equation. So I believe by now you understood how to use the discriminant to determine the nature of quadratic roots. So in this video here, we talked on the symmetric properties of quadratic roots. Thank you very much for watching. God bless you.